Alright, welcome back to class. Under the sound course, okay, we have discussed extensively many aspects of sound. We want to continue, and this time around, we are looking at wind instrument and percussion instrument, okay? So, what you need to understand about the wind instrument and the percussion instrument is that, number one, the wind instrument is, example like your organ, those things you have to blow wind into it in order to make a sound. While the percussion instrument has to do with something you play, like your drum, the xylophone. Please take note. Xylophone, xylophone, right, is an example. I hope this spelling is correct. Okay, xylophone is an example of what percussion instrument and your drum. Okay. Now, when we look at resonance, what is resonance? Every instrument has its own natural frequency. Alright? It has its own natural frequency. So, if an instrument is made to vibrate at that natural frequency, then we say that it is forced vibration, okay? And remember, that forced vibration is happening at its own natural frequency. That's what we call resonance. Take note. The word resonance is what? Setting an instrument, alright, into vibrating at its own natural frequency. Okay, let's take for example a tuning fork. So a tuning fork with and one end is open, alright, a tuning fork with one end open. Okay, now one end of this tuning fork is open and it is made to vibrate. Now the first note will be heard, or the first resonance will be heard when the echo makes a vibration in this format, okay? Now this vibration is not half. Remember, when we say half is something of this form, right? Then one it makes this form, right? So now if we have half of half, which is what we are seeing here, that is what? Quarter, right? So we say that what the length, the length of the echo is equal to quarter wavelength. Isn't that? That is a quarter wavelength, right? So remember, this is the first note that will be made, and this is also known as what? Fundamental frequency. So fundamental frequency is equal to what? Or equivalent to what? 1/4 lambda. Alright? And remember V in wind, just like we stated before, is what? F lambda. Alright, F lambda. So if we simplify this and we want to use the length, we don't know the wavelength, but we want to use the length, cross multiply. So the length will have the 4F, right? So V will have the what? 4FL. This is, alright, a formula that will help you to calculate all this stuff, right? Now remember, this is fundamental note. So when you have velocity, alright, and you have the length of the vibrating colon, you can determine your fundamental note, okay? Now, there's another harmonics that will be sound, okay, which is your next overtone, or we can say next, what we call it? Resonance, okay? Remember, it's making a loud sound now, okay? So resonance, we have the first resonance, and the next resonance which will be heard, okay? The next one could be in this form. If we reduce the volume of, let's say, if this is water, we reduce the volume of water to this level, okay? Now, we could hear a note, let's go this way. So, this on this way, on that way, okay? Can you see that? Alright? This is when the next note will be heard. When the air column vibrates in this format, okay? Now this is a complete half now. Can you see? That's a complete half, and this is another quarter. So what you see? That is 3/4, okay? So this is 3/4. So the length of this air column, alright, is equal to what? 3/4 of what? The wavelength. And remember, for you to make the first note, you just need a quarter. Now we are having 3/4, okay? So what does that show? It shows that what? After the first harmonics, or resonance, the next resonance or harmonic will be three times the first harmonic. Are you see that? Alright? The next one also is going to be 5. So if we keep drawing it, we are going to see that. Alright? It takes an odd number, right? Odd number series, okay? So this is a series of odd numbers. So the next one will be what? 7 what? F naught. Can you see that? So remember, this is the first harmonic, second harmonic, third harmonic, and fourth harmonic, and so on and so forth. But this is the first overtone, second overtone, and third overtone. So you start counting your overtone from the second one, while the harmonics you start from the first one. Okay, I hope you understand that, alright? So the next thing is what we call quality of sound. Now, what is the quality of sound? The quality of sound can best be understood when you look at different instruments, okay? Now, different instruments can make the same note of the same frequency, alright? The same frequency, identically, or the same tone, alright? But the quality of the sound or the nature of the sound will be different, okay? If you play a guitar and an organ, at the same note or frequency, you know it's the same note, but the quality or the sound effect is different. The sound different in the air. That is what we refer to as the quality of sound. So different instruments have different quality of their frequencies that they emit, alright, even at the same value. Are you getting me now? So we now talk of octave. Octave is more like, for instance, if we have a fundamental frequency of, F naught, alright, a higher octave would be 2 times this. Are you getting me? The frequency of the first octave, the next octave would be what? 2 times that frequency. Are you getting me? The next octave 2 times that frequency. So also for this one, the next octave for this will be 2 times this frequency. Alright? 2 times this frequency. Octave. Are you getting me now? So now these are the 3 things. You can see the formulas that are outlined for the calculation. So I will start dropping questions and answering them according to the YX standard and JAMB standard. Thank you. Okay, one more point, just keep my mind. Now, take a look that the diagram that was, that you saw before, is when we have a closed-ended pipe, okay, a closed-ended pipe. What if we have an open-end pipe? What if we have an open-end pipe? What will be the first note or fundamental frequency? Now, when we vibrate the air colon, alright, it goes this way. Can you see that? So what can you see? If you vibrate the air colon, it goes this way. So this is produce the first loud sound, okay? That is our first frequency. And the length here, how many lambda can you see here? This shape here is already, this shape here is quarter lambda, and this is another quarter lambda, right? Quarter, this is half. If we have another one this way, that will make it complete cycle. Okay, so this 2 is half, and this other 2 is half. So the whole thing is just half. Okay, so therefore, length is what? Half of what? Lambda. The length overtone will be had in this format. This is the length overtone or the length harmonics. Okay? The length harmonics will be had when the air column vibrates in this format. Okay? So this vibration now, how many lambda can you see here? This is 1 lambda. So the length here is equivalent to 1 complete lambda. Okay? So how many half lambda is in 1? 2. Can you see? And it goes on and on. So the harmonics will be fundamental note, alright, 2 fundamental note, 3 fundamental note, and what? 4 fundamental notes. So this is first overtone, second overtone, and third overtone, and so on and so forth. I hope you understand that, okay? So this is for open-ended. and this is closed ended. So I'll just outline maybe like 3 questions, then we can solve and wrap it up there. Alright, so welcome back. So we want to solve questions as you can see on the board. Okay. Alright, these are the questions I want to quickly solve. There are more questions I will be solving quickly, but let's start with this one first. Now you can see this diagram. The question says use this to solve 1, 2. Sorry, 1 to 10. So we are using this diagram to solve 1, 2, 10. Okay, so look at the diagram very well. Okay, you can see there are 2 different ways. The first one B and the second one A. Alright? Now both of them completed their motion at the same time, but one is having a more frequency than the other. A vibrates more than B, alright? B just makes one cycle, A makes 1 and 2 and 3. This is how to interpret the diagram, okay? Before you start solving the question. Alright, let's start solving. So if the frequency of waveform A is 60 Hertz, okay? The period of waveform B is a very simple one. You can quickly answer that, okay? But let's just try and apply some formula to get that, okay? Now, let's go. So, what is the first thing? You know, the first thing that connects A and B is the same time. They all have the same time, okay? And you know, frequency is number of oscillation, right, over time taken. And they both have the same time. So, whatever time A is the same time for B. So, time will have the number of oscillation over frequency. Can you see that? Now, what is the number of oscillation for A? Look at the question, okay? If the frequency of waveform A, so let's talk about A now. How many? 1.5. So A made 1.5, 1.5 cycles. Alright? Then what is the frequency? 60. 60, okay? So the time for A is what? 1.5 over 60. And remember, time for B is the same. So what are we looking for B? Is that the period of the waveform B is, now we're looking for period for waveform B. So period. So what is the formula for period? Remember, period is what? Time over number of oscillations. So since the time, we have the time already, time B, cross multiply, that will be period times what? Number of cycle made or oscillation. So what is our time? Our time is this is our time, okay? And we're looking for period. Are you getting it now? Alright? So let's now go back to this formula. So we're looking for period. That will be what? Our time is 1.5 over 60 divided by number of oscillations. How many oscillations did B make in that time? Can you see? It's just one oscillation, right? Look at this. 1. Half and another half. That is one oscillation. So what does that tell you? That tells you that what? You can put 1 here. So the period for B is what? 1.5 times 1 over 60, right? So 15 over 10 times 1 over 60. Alright, 15 here is 1. And the 15 here is just 4. Okay? So that is what? That is 1 over 40, right? And 1 over 4 is the same thing as 0.25, right? So 1 over 40 will have is 0.025 when you press your calculator. 0.025 seconds, okay? So our answer is option A. Option A is the correct answer. Is that taken? Alright? Let's try the next one. Now the next one. The next question. The number of times 3 waves passing a given point in the medium in 5 seconds, sorry. In 5 seconds is, so what will be the number of waves passing, you know, those students try to stop. So let's continue. Alright, so now we have now we are in number 2. It's like the number of times v. So we're looking for the number of waves of v passing a given point in the medium in 5 seconds. So how many waves will pass through a point in 5 seconds? That's just the simple explanation of this question. I get it. So let's solve that here. Let's solve that here actually. So if we solve that here, so we're looking for number of waves, alright, in how many seconds? So let's call it S. Number of waves is S, and the time is 5 seconds. Okay? So remember, we are talking about waveform A, right? Waveform B. And we already have period for B. So the period of B that we got was 0.05. So our period for B is 1/40. Remember that, okay? So if we have period as time over number of oscillations, then 1/40 is equal to time. What is time? 5 seconds. How many oscillations is in 5 seconds? Do you understand that? Alright, so cross multiply, that will be what? That will be that S is equal to S times 1, S 40 times 5. That will be 200 waves. Alright? So 200 waves or 200 seconds. This is it. Option C. Did you see how I'm solving that? Alright? Now the next one is if the speed of the wave is 5 meters per second, the distance between the two successive particles of wave from A, which are in phase, is what? Now listen, if the speed of the wave is 5 meters per second, right? And remember, both of them have the same speed. Why? Because they all cover the same distance at the same time. Can you see that? They cover the same distance at the same time. So they both have the same speed. Okay? So if their speed is 5 meters per second, alright? So now their speed is what? 5 meters per second. That is what the question says. The distance between two successive particles of waveform A, which are in phase. So two successive particles, let's say two successive squares, that is in lambda. Alright, that's wavelength. So they are asking for the wavelength of A. Okay? So remember, G is equal to F lambda, right? So what is the frequency for A? Remember, the frequency of A has been given to you at what? 60 hertz. Can you see that? This is frequency of A, 60 hertz. So what we have? 5 equal to 60 hertz times lambda. So our lambda will now be what? 5/60. 5 here is what? 1, and the 5 here should be that should be 12, right? So 1/12, when you press your calculator, 1/12 will be what? Now let's convert it to meter, okay? Because this is meter, right? Let's convert it to centimeter. So that will be 1/12 times 100. When you want to convert meter to centimeter, you multiply by 100. So 1/12 times 100, that will give us what? So you can say 4 here is what? 3, right? And you can say your 4 in 100 is how many? 25, okay? So 3 in 25 is 8, alright? For 3 in 10, that is 3. So you have 3, 3, 3, and so on and so forth. So centimeter. So the wavelength is what? 8.33 centimeter. Can you see that? So this is the wavelength. I hope you understand that, right? So let's go to the number 4 question. Alright? Now the fourth question, I'd like to solve it here. So this is the diagram for the fourth question. Let's of all take note of how many waves. 1, 2.5. So 2.5 waves, right? Now, here's the question, okay? In the diagram above, shows part of the waveform for a wave traveling with a speed of 30 meters 320 meters per second in air. If the distance AB is 5 centimeters, the frequency of the wave is, now you're looking for frequency of wave and you already have distance at 5 centimeters. So distance is what? 5, is it 5 centimeter? 5 meter, right? Good. Now, from there to here is 5 meter. But from there to here, how many ways do you see there? So you have your distance as 2.5 lambda. Can you see? 2.5 lambda. So lambda is now what? Lambda is what? Lambda is now what? Do you understand? From here to here, 1, 2, 1, 2, and a half, 2.5. So it means that 2.5 lambda is equal to what? 5 meter. Why we need this? Because we are looking for frequency. Alright? And we already have speed. So speed is equal to what? Speed is equal to frequency over lambda. Alright? So we have speed and we have frequency. Sorry. We have speed and we have lambda. How? This is where we get our lambda. Alright? So our lambda is now x equal to 5. Lambda equal to 5 over 2.5. 5 over 2.5, that is what? That is like 2, right? Okay, so 2 liters. So you can put 2 there. So 320 meter per second, applying this formula, V is equal to F lambda. 320 meter per second is equal to F. What is F? Our F is what we are looking for times 2. So F is what? 320 over 2. And that is what? That will be 160, right? That will be 160 hertz. This is the correct option. Now the last question for now, before we move into solving other questions. So we have what? Now look at how many wavelengths? 1, 2 and a half. 2 and a half wavelengths again. So let's read the question. In the waveform shown in the figure above, energy is transmitted from what? P to Q in how many seconds? 5 times 10 power minus 3 seconds. The question says frequency of the wave is, so we're looking for the frequency now. We have time and we're looking for frequency. Remember, frequency, as this topic was very simple. Frequency is what? Number of oscillations over time taken, right? So that will be what? How many oscillations do you see here? 2.5, right? So 2.5 over time, 1 time, 5 times 10 or what? 3. So what we have? 5 times 1, 5 times 0.5. So 0.5 times 10 to the power. This 10 to the power minus 3, once it goes up, it becomes 10 to the power plus 3. And that is 1000. So 0.5 times 1000, that will what? That will what? 500 hertz. Can you see? So the correct option is 500 hertz. I hope you enjoyed this class and you understand all that we have taught so far and all the calculations that we have done so far. Thank you. We're still going to drop questions on sound. Alright, purely sound, okay? So we're just here to do some of these calculations. Alright, thank you. Hello, welcome back. This is Mr. Brain. Can we solve this question on the board very quickly? The rotating disc in a siren has 40 holes and makes 30 rev per second. The frequency of the sound emitted by the siren is. Now, for you to get the frequency of the siren having as many holes, all that, and making 30 rev per second, revolution per second is simply as frequency, okay? So if this is the frequency, alright, for if this is the frequency of the rotation, then the frequency of the sound will be 30 times 42, okay? So the answer, alright, is frequency equal to what? 30 times 42. And that will give you what? 1, 2, right? 1230. 1230 hertz. I hope you understand that, okay? Now, the second one, very quickly. Now, it says if a wave is represented by the equation y equal to this. Now, this is the equation of the wave, y equal to 0.20, alright, sine, okay? 0.4, now, use this 0.45 to expand the bracket, okay? So 0.4 pi times n, that's 0.4 pi x, alright, minus 0.4 times 60. 0.4 times 60, that's what? 24, right? 24 times 3. Okay? Right? Where x and y are in centimeters, and t is in seconds, the velocity of the wave. Now, you're looking for the velocity of the wave. Okay? Now, we're looking for what? The velocity of the wave of this question. So, what will be the velocity? You have to compare this equation. You compare it to y equal to a sine, alright, kx minus omega t. Can you see that? Alright? So you have what? Omega as what? 2 pi, sorry, 24 pi, right? 24 pi. Meanwhile, the formula for omega is 2 pi x. So what does that mean? It means that our x is 12. 12 half. Can you see that? Alright? Okay? Now, the next thing is, now k and this. K is what? K is equivalent to everything here. Can you see? K is this, y omega is this one. So our frequency is what? 2 pi. Now our K is what? 0.4 pi. Okay? Meanwhile, the formula for K is 2 pi over lambda. So what does that mean? When you cross multiply, your lambda is equal to 2 pi over 0.4 pi. So pi will cancel pi. When you divide 2 over 0.4, that will be it's more like 20 over 4. Okay? When you move this decimal to this side, okay? So 20 over 4 is 5, alright? So your velocity, which is f lambda, alright, is actually what? Is actually what? V equal to what? That would be V equal to what? F 12 times 5. 12 times 5, that is 60 centimeters per second. So this is the correct option, okay? So we are solving more questions.